Artur, and I just wanna briefly present the Marble application where you can mine and explore mesh terms and abstracts from PubMed publications. And so application was developed on both Windows and macOS operating systems. It consisted of 4 steps. I will start briefly from the core step, which is second step, abstract mining. And so the input are the midline format, it's midline format file from PubMed website. So user can upload it manually here. However, there is also PubMed Search, which is first step. So if files are not too large and not exceeding like dozens of thousands of records, then this will work fine from here. However, if there are like some hundreds of thousands of publications required to download, then there will be API limit. So here is the hyperlink, and so it's better for user to manually download those specific searches and just upload them manually here later in the second step. However, let's show everything from the first step. We can type any term here, but there is also autocomplete. So let's proceed with this, so it will be just quicker. Email is mandatory here due to the API restrictions and other things related to PubMed. And yes, it's worth mentioning that by default it will basically mimic the search and download in the same way as it is from the PubMed website. However, user also can restrict it to specific number, like maximum number of results, but let's keep it default. And there are also advanced filters where we can specify the range of the date, provide the custom, and a few others which you can see here. But as I said, let's proceed with the default ones. So for this search, we have over 500 records. So this is downloaded. Everything will be stored in downloads, so user can see it there. And there is also always option to save it. Again, it will be just one directory above the app. Let's proceed to the second step then. And yeah, as I said, this is the core step. And this step can process hundreds of thousands of abstracts. And so there are like six, let's call them dictionaries with biomedical terms. And user can also upload its custom terms here. All the terms and all the steps are explainable and described. And there are also like hover question marks. And let's proceed with custom terms. And every upload in entire project and validates correct file format, input file format. So for example, if I wanna upload accidentally something that it's not in required format, let's try to do it. It will trigger the error. Yes. And so here is the required format for these upload custom terms. And these are the, so basically 1 term per line, as says. We can also give optionally some name. Let's call it test terms. And let's upload the correct ones now. So we have them, as you can see, 176 uploaded file name, and that's fine. And this is proceeding throughout all the records and that we obtain from the first step, and basically trying to match all these 6 terms categories and looking them in every single record, every single abstract. Again, we can save them. Here are the mining results. They already automatically saved here, as you can see, some basic mining result statistics. And so we have from among these over 520 abstracts, we have 369 with matches that they contain at least one of our terms. And worth mentioning, so all of these 6 categories, they looking in MH fields in midline format file, but additionally our custom terms or default veterinary terms, if we want to provide anything here, will also look in abstract text itself as well for those terms. Here is preview of this file that was stored there, as I said, so we don't have to go into download directory. We can just quickly look it here from here. And yes, so here are our columns, and this is what we extracted from every single record that I mentioned. So journal, type, mesh terms, and our categories, disease methods, etc. But we also extracted demographic information from there. And yeah, if user wants to see, let's say, abstract, you can expand it here. But there is also option to quickly see certain abstract just by clicking on it. And let's say if we're interested in 5 specific records, then we can save just these selected ones, either as a txt, which was just done now, or CSV. And yeah, this is done. We can also clear the selected, start again. There is a hyperlink, so we can just visit on PubMed website for any specific record. And let's just briefly show you downloads. So these are the selected results in CSV, txt that just I just downloaded. And yeah, let's go to next step, data visualization. So this proceeds, as you can see, the data from our files from the first step and the second step. So basically the PubMed midline file, let's call it as a raw file, and then our mined abstracts here. And yes, so here is this midline format from the first step, as I mentioned already, and some basic information of like publication, journal distribution, types, and abstract length distribution. So yeah, basic statistical information here, percentiles about length. For this search, there have been 3 empty abstracts, for example. And yes, every plot is interactive, so we can use it and just zoom it in if we want to. And mine abstracts, so these are the information from our second step that we just completed. And so we can see here something like word cloud, and we have a lot of toggle bars throughout entire projects to set some threshold, etc. So we can see like more words here. And so this is term category coverage, and you can see the distribution from these mine abstracts. So, for example, for our test terms, they've been found in 154 abstracts total, and unique among these terms, 42 are unique, and total term count for our test terms that we uploaded is, in this example, 227. It's higher because they could occur, like the certain term could occur multiple times, and so that's why. And yeah, again here, abstract coverage by term, distribution breakdown. And here we can see the our terms more specifically. And so let's say test terms, if we want to see more of them. And here we can see the counts for them. And for this step number 3, the last important thing is that we can generate the PDF record. We can give any name here and change this one as well if we want. And this is generating the PDF report that will consist of all the plots that I just show you from both midline data and my abstracts, and it will be automatically saved. And let me just show it here. So it's under visualization results, and here. And this is our report. Just briefly, as I said, it consists of all this that we just saw, plus some additional statistical analysis. Let's go to next step. So in this step, it generates 4 different networks, as you can see, plus matrix representation. Feel free to stop if you want to read it. And our generated files are here, also with descriptions. And yeah, everything, as I says, it's automatically downloaded when completed. However, there is also always option to save it again, which will be just in download. And I will just quickly maybe show it. So we have, here are our network files that we just generated now, mining results that we done, and from the first step, it's here. And yeah, that was stored. And so let's come back to the application. This is the Sankey diagram here. We can see all the terms here. Our test terms. And we can change the occurrence here. This is for exploration for the user, so a lot of tweaks can be done. And this is the most important part of this step, where user can explore all the connections and co-occurrences between all the terms among all the abstracts or the records that have been processed. So as I mentioned already, there are 4 different networks. Let's start from the first one, complete network, which is here. And this is interactive, as everything here. So we can hover specific node. And yes, let's check this one, for example. And so we selected this one, and it says degree 33, which is correct for this threshold that we have here. This was the default too. And worth mentioning, all the thresholds among entire projects, they are like automatic. So the system detects the size of specific file that will be processed and adjust the threshold. So for example, if we have like a very large network that consists of like dozens of thousands of nodes, this co-occurrence threshold will be by default set much higher, just to generate the first network quicker. However, and that's why a user have this this toggle bar here, so it can change it manually. And so let's explore this specific node in more details. So degree for this threshold, which is co-occurrence 2, it's 33, but the total number of neighbors, the degree is 99, and that's what we would see if we set a threshold to 1. But without changing the threshold, we can see the full scope and all the details for any specific node and term. And we can also see the PubMed IDs. This can also this also allows us to go to the source for any of PubMed IDs we want, and we can see all the neighbors if we're interested to explore it. And it works for any other node here. We can also highlight specific, let's say, yeah, we want to see the test terms, so these are the highlighted. And we can also search for specific term here. So let's say we are interested in anemia. And too much is found in this network. And here the anemia and this one. And again, we can explore them here. Let me remove this. And just quickly show you there are like different terms. The naming is automatic, so you can see this is test term network. Again, with all the information below. And lastly, let me explain this threshold. So if I move it to 1, this works very quickly because this network is not very large. However, as I mentioned, if we process like very large files and networks automatically, there will be like warning describe and threshold activated to some certain point. I think it's set to around 2000 nodes by default to don't generate too large, but then if user wants to, then it can force to generate basically any size of the network. And again, for like very large networks, we might be interested to go beyond 50 for the occurrence threshold. And then we can just select this and put like any specific threshold here. Lastly, for this step, matrix heatmap. And you can see here those three matrix heatmaps. Again, we can explore, and depending on the threshold that we want to see. Here are some key statistics for these two terms. So our test terms with most disease associations, etc. A second matrix here. We can change this as I mentioned. And the last one. To navigate, we can use either next or previous step, which I was doing here. And I didn't mention that the entire project works in both light and dark mode, and we can navigate from the top but also from the side. And and the last thing, if user wants to start and proceed with new search, instead of closing the app and restarting, there is reset button, and now we can start from the scratch. And that's it. Thank you very much.